In this video, I'm going to talk about the spectral heat rate and emissive power. But first, let me revisit the definition of a spectral intensity. Spectral intensity is a function of lambda, theta, and phi, and is associated with the energy emitted by a differential of area, which is located on a surface whose normal is n, and we are interested on the heat flux of a surface that is at a distance r from the area and located at some theta and phi angles. So it also will have associated a solid angle at that position. We have to notice that this differential of area is associated with the actual area that is projected in the surface and is given by dA cosine of theta. Spectral intensity flux is associated with the heat rate per unit area, and in this case will be the projected area, dA cosine of theta, and at a solid angle d omega, and at a wavelength interval d lambda. So we are considering an interval of wavelength. Spectral heat rate, denoted by dq lambda, is the heat rate at a wavelength interval d lambda, and is defined as the spectral intensity emission multiplied by the projected area dA cosine of theta and multiplied by the solid angle. The spectral heat rate flux dq double prime lambda is the spectral heat rate dq d lambda divided by the area, the emitting area, divided by dA1. So it's equal to E lambda dA cosine of theta d omega divided by dA. This dA is cancelled. Spectral emissive power is the total power emitted at certain wavelength. Is defined as the integral of the spectral heat rate flux over the whole hemisphere. By definition, the heat rate flux is given by the spectral intensity multiplied by the cosine of theta and the solid angle. By expanding the solid angle as sine of theta d theta d phi, we can define the integral limits to accomplish the integral. On the other hand, the emissive power considers all possible wavelengths, and therefore is defined as the integral over the total wavelength over the total spectrum from 0 to infinity. While the spectral emissive power considers all possible directions, the emissive power also considers all possible wavelengths.